Well, we're back with 6.3 and we're talking about linear functions. Our goal here is to write a linear function from a graph or a table of values. But first, let's talk about what a linear function is. A linear function is a function whose graph is a non-vertical line. And the reason it's non-vertical right here is because remember, if we have a graph and this is the x-axis and the y-axis, if it's a vertical line, the slope is undefined, right? So, in which case, say this was 2 right there, the equation of that line, or the function of that line, is x equals 2. So, a linear function is a function whose graph is a non-vertical line, so it has a slope. A linear function can be written in the form y equals mx plus b, where m is the slope and b is the y-intercept. So whenever you're talking about linear functions, it's just like an equation, right? And we're familiar with y equals mx plus b. That's slope-intercept form, right? And we always want to think about writing the equation or the function in this form. So first, let's talk about writing an equation or a linear function given a graph. So let's say we have this graph here, and we want to write a linear function for these points. Well, first, let's recognize that they all fall in a line, right? So that's what linear means. Nonlinear would mean they were in different parts, right? We couldn't draw a straight line through all of them. So this is going to be a linear function, or just like an equation of a line, as we have been calling it in the past. So for this, we want to take 2 points and find the slope. So we're going to use m equals y2 minus y1 over x2 minus x1. So I'm going to use I'm going to use 0, -3, and 2, 0, right? Because zeros always make everything easy. So I have -3 minus 0, or you can do 0 minus -3, over 0 minus 2, right? This is my x2 and y2 that I chose, and then this one was the x1, y1. So m equals, so -3 minus 0 is -3, and 0 minus 2 is -2. So that ends up equaling m equals 3 over 2, right? And you can leave it like that. It's easier because you can see the rise over the run as opposed to 1.5. Okay, so that was my first step. Now I'm going to take m equals 3/2, and I'm going to take one of these points and plug them into y equals mx plus b. So if I have m equals 3/2, and I'm going to choose the point 2, 0, just because it has a 0 and it's positive 2, and plug it into y equals mx plus b. So I'll plug in 3/2 for m, my x and y there, so I'm going to plug in 2 for x and 0 for y plus b. So now I'm going to solve for b, right? Well, 3/2 times 2, this is like 2 over 1, so those simplify. So that gives me 0 equals 3 plus b, -3, -3, -3 equals b. So now I have -3 equals b and m equals 3/2. So step 3, I just substitute those back in to y equals mx plus b. So I get y equals 3/2 x minus 3. And that is your linear function for those lines. But since we're writing a function, this is usually how functions get expressed, with f of x instead of y. F of x is just saying, what is the function of x when given a certain value of x? So f of x is the same as y, just for the record. Okay? So here are the steps that you want to follow to do the process that we just did. So writing a linear function using a graph. Step 1, find the slope by selecting 2 points and using the slope equation, which, remember, the slope equation is, oops, I didn't mean to change the color, but we'll leave it. M equals y2 minus y1 over x2 minus x1, right? So that's the slope equation. Step 2, substitute m from step 1 and one of the points x, y into y equals mx plus b and solve for b. So for the point x, y, you can choose any point on the line. Step 3, substitute m from step 1 and b from step 2 into y equals mx plus b to write the linear function. And that should be a period. Okay, so now let's look at writing a linear function using a table, and you're going to see that these exact same steps apply. So really, these steps are writing a linear function using a graph and a table. It's just a little bit different with a table. Okay, so here we have a table just with x and y, and the x and y could be anything. It could be cost and number of pieces of clothing that are sold. I mean, it could be anything in a table. These represent points though. -3, -3, 9, that's a point on a line. -3, 9, for lack of a better example. -2, 7, something like that. -1, 5, something like that. And you'll notice they all are lying 0, 3, about on a line. This is obviously a really rough sketch, but you get the picture. So we can use those same steps that you should have just written down in your notes. So we want to find the slope. So I'm going to use these 2 points here because there's a 0 in this one, and it just makes that always makes it easy. So I have m equals y2 minus y1 over x2 minus x1. So I plug in my points. So 3 minus 0 over 5 minus a -1. That equals 3 minus 0 is 3, 5 plus 1, right? Because that makes a positive. 5 minus a -1, so 5 plus 1 is 6, so that equals 1/2. So m equals 1/2. So now I'm going to take that m equals 1/2, and I'm going to use that point 0, 3. So this is step 2. I'm plugging these into y equals mx plus b, right? So here's my x and my y and my m. So my y is 3, my m is 1/2, my x is 0 plus b. This equals 3. Anything times 0 is 0, so 3 equals 0 plus b, so 3 equals b. And now for my final step, I plug my b and my m into y equals mx plus b, so I get y equals 1/2 x plus 3. And there's the linear function. Okay, so this is, you're always going to have the x and the y in the linear function, right? Because now I could plug in anything for y and solve for x, and I'll find out when y is this, what is x, given this linear function. Okay, so that is all you really need to know for linear functions for right now to get you started. So just one last thing I want to look at is this word problem. We have the earnings y in dollars of a nighttime employee working x hours are represented by the linear function y equals 7.5x plus 30. The table below shows the earnings of a daytime employee. So y equals 7.5x plus 30, that's the nighttime employee. And if they work x hours, you know that they're making $7.5 an hour, right? Because that's what's being multiplied by x. And then 30 is just some constant. Maybe they get that per shift, or that's like a gratuity they get. Regardless, we can tell that since it tells us that x is the number of hours, then 7.5 is the rate that they're being paid, at which they're being paid, right? The rate, the slope, it's all the same thing. So now if we look at this table, this is for a daytime employee, right? This table here. Well, for every hour they work, how much is the change? How much more? What's the change that's happening in their pay? Well, it's going up 12.5 every hour, right? So that's the slope. That's the constant. That's the constant change that's happening. So since it's constant, we know that this is a linear function, right? If say we were looking at another table and it wanted to know if it was linear or nonlinear, since the slope, the change, is constant, then it's a linear function. Again, if it was not, say it went 12.5, then the next hour it went up 14, and then the next hour it went up 18, that would be a nonlinear function, right? But since it's the same change between each x and y, every hour they're getting $12.5, it's a linear function. Well, since they're getting, the slope is going up the change is going up 12.5 every hour, right? That's y is changing for every 1 hour x, y is changing 12.5. So that's our slope. So that means that the daytime employee is making more money per hour, right? Their slope is 12.5. Their rate is 12.5 versus the nighttime employee whose rate is 7.5. Okay, so that is all you need to know for right now, and that'll get us started.